Right now, as you watch this video, a tiny message travels across the internet through a massive, hidden global machinery. Whether you're streaming a show, checking your bank balance, or sending a direct message, a physical system is doing the heavy lifting. Almost nobody thinks about how it works, but this invisible exchange is happening billions of times every single day. It wasn't always this seamless. In the early days, to share information between computers, you had to physically copy it onto a disk. Once local networks appeared, a massive problem emerged: keeping data accurate across multiple machines. Look at this network of computers. Imagine a hospital where every machine holds its own copy of a patient's medical history. If a doctor updates the file on their desk, the 11 other machines have no idea. You instantly have 12 contradicting records. Without a single, universally recognized source of truth, sharing data across a network quickly becomes dangerous. To fix this, someone had to be in charge. The solution was to appoint one central, powerful machine to hold the official, permanent record. This diagram outlines the hierarchy. The central machine managing data is the server. The everyday devices connecting to it are the clients. The relationship is strict. The clients always ask, sending requests to the center, and the server always answers. This system, one machine managing data and many others requesting it, is the client-server architecture. It keeps the modern internet from collapsing into chaos. Let's track exactly what happens when you use this system. The process begins the exact millisecond you type a web address into your browser and press enter. Your browser constructs a specific request, mapping out the page, data format, and identity. The client wraps this in HTTP rules, ensuring both sides speak the same language. The packet queries the DNS, translating the web address into the target's exact numerical location. Your data doesn't just wander aimlessly. It navigates a strict grid of rules and directories to find its target across the globe. The request arrives here, at a data center. A server is a specialized, powerful computer kept in a facility like this, running around the clock. It works like a restaurant. You are the client ordering, the internet is the waiter, and the server is the kitchen. When your packet hits the server, it first passes through the application layer. This logic brain filters your request, verifying details. Once confirmed, it sends a query to the database, which isolates the requested record and pushes it back up the chain. This tiered separation makes the server an active gatekeeper that secures and processes every request before a single byte of data moves. The logic layer takes those raw records, packages them into a finished response, and shoots the data back across the network to your device. Your browser receives this package and translates the code into the text, images, or video that instantly populate your screen. That entire round trip, outward bound, verified by the logic layer, fetched from the database, and rendered on your display, takes less than half a second. This round trip involves thousands of miles of fiber optics and multiple logic checks, all completed before your screen can even refresh. Multiply that half-second sprint. This exact cycle is happening simultaneously for billions of users worldwide. Notice where the information stays. Your sensitive banking details don't live on your phone. They remain locked securely on the central server, giving administrators total control. When developers push an update, that single fix cascades out, instantly improving millions of connecting clients. And when an application explodes in popularity, engineers handle the traffic by adding more servers. The architecture grows with demand, so your phone doesn't have to work any harder to stream a high-quality video. Compare this to a peer-to-peer network, where there is no central hub. In P2P systems, every connected user has to share the heavy lifting of storing and serving data to each other. The internet is a physical, relentless cycle of asking and answering that allows billions of machines to function as a single, coordinated system.